Italian wall lizards, or Podarcus sicilis, are a small species of lizard home to Bosnia, France, Croatia, Italy, Serbia, Switzerland, and Slovenia. They generally hold an insectivorous diet, but it's sometimes supplemented by plants. The habitat of the Italian wall lizard reflects its diet greatly, as they live in rocky Mediterranean areas with shrubby plants with an abundance of insects. Podarcus sicilis are part of the kingdom Animalia, phylum Chordata, class Reptilia, order Squamata, family Lacertidae, and genus Podarcus. Italian wall lizards have dozens of interesting subspecies, including Podarcus sicilis clemeri, who features unique blue skin. One of Podarcus sicilis's latest ancestors is the reptiliomorph labyrinthidans of the genus Cassiniera, who were tetrapods living in the late Carboniferous period, who are among the earliest to evolve from amphibians, and are believed to be the root of all birds and reptiles. The Cassiniera marked a clear shift from the semi-aquatic amphibians in the swamps of the late Carboniferous to a strictly terrestrial life. The fossil record of the genus Cassiniera is among the earliest we see this. Hylonomus illi, alongside footprints found in Nova Scotia, are the earliest known definitive reptiles in the fossil record. Hylonomus illi is an important ancestor because it marked the clear start for all known reptiles and a divergence away from the previous reptile-like tetrapods. An extremely important ancestor of Podarcus sicilis are the early squamates. The order of squamates all have lighter jaw adductors than other reptiles, which led to them having lighter heads and thus smaller bodies, as you can see on the graph on screen. These smaller jaw adductors also impacted a reduced bite force, but an increased agility, which allowed them to eat insects more effectively. The order of squamates emerged in the late Permian, or about 250 million years ago, and are a very large order that include many species of snakes and lizards. Another important ancestor of Podarcus sicilis could be an early Lacertidae, which put Podarcus sicilis in a family of small, fast, bug-eating lizards. Genosichia ulmensis colm is a Lacertidae that adopted a herbivorous diet and showed a clear link between gigantism and herbivory in Lacertidae. Genosichia was dated back in the fossil record to be from the early Miocene, or 23 million years ago, and is important to keep in mind later in the presentation. In 1971, a group of Croatian biologists transported 10 adult Italian wall lizards to the Croatian island of Podmakaru from the adjacent island of Podkapishti. The lizards were only native to Kapishti, but both islands shared very similar microclimates, and the scientists wanted to experiment how the lizards would succeed in the new environment. The island of Podmakaru, however, did feature a lot more vegetation than Podkapishti. Podmakaru also featured significantly less ground predators than Podkapishti. These islands were so close together that you could even see Podmakaru from Podkapishti. This was done intentionally, as their transplant was supposed to replicate a natural phenomena such as a storm or the islands colliding, which would have brought the lizards to the new island. What the scientists were creating was an evolutionary bottleneck on the island of Podmakaru. In this new environment, the lizards were able to thrive. When scientists returned in 1990, they discovered the population on Podmakaru was drastically different from that on Podkapishti. However, DNA evidence revealed that the lizards on Podmakaru were all descendants of the 10 colonizers from Podkapishti. The scientists described the lizards on Makaru as having a larger on average size, shorter hind limbs, lower maximal sprint speeds, and a different predatory response. Scientists returned again in 2008 and discovered the lizards had a completely different head morphology, having larger, wider, and taller heads than their Kapishti counterparts. They also had an increase in bite force. This was likely due to a shift in diet where the Makaru lizards ate primarily plants while the Kapishti were insectivores. The scientists confirmed this hypothesis as they found out the Podmakaru population ate significantly more plant matter than they did insects, which is very contrary to the Podkapishti population, which were primarily insectivores and only ate a small amount of plant matter. The most exciting discovery was that of cecal valves within the Makaru population. These cecal valves were not present in the Kapishti population at all. Cecal valves are present in other species of lizard, but this trait is unique to this population of Podarcus sicilis. meaning that no other Podarcus cyclus population has these valves. What cecal valves do is they create small pockets in the lizard's digestive tract that slow down digestion as to break down cellulose or plant matter more effectively. This adaptation likely occurred due to there being more vegetation on Podmakaru and the population adopting a higher plant diet in response. Due to all this, the lizards on Makaru could be classified as their own subspecies, meaning that a small population successfully evolved or had speciation occur within a short human lifetime. This also provides proof to Darwin's theory because nature selected for better plant-eating traits within the Makaru population, giving the new population a bigger size, less mobility, a stronger bite force, and above all, cecal valves.